Um, we were talking to see what, for number 2, what do you think it is?
For the homework?
Yeah, or the group meeting. It says in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master's degree, doctorate, of people who manage successful startup companies in the United States and Korea. You want to determine if education level differs between managers of successful companies differs between these two countries.
We were thinking it's proportion.
I think you're right. I think it might be G because you're determined between.
Are you guys in the group meeting assignment or like the actual preparation assignment?
They're the same thing.
Oh, okay. I hadn't checked this week.
I think you're right though, Megan. I think it is because it's testing that part that says it differs between these two countries. So it's just doing between two countries. So I think you're right.
So the test of two proportions?
I think so.
You guys said G?
That's what we think.
Okay.
Next one.
Sure. A human resources manager reported data from a recent involuntary reduction in force (REF) at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which test is most appropriate for the analysis? I think it's D.
Yeah, that's what I
What
think.
did you say?
D, as in dog.
D?
Independent sample t-test.
Yeah.
What do you think, Daniel?
Going back and reading some of this stuff. 1 second.
There's that document she attached. It's like the flow chart.
Statistical test flow chart.
Yeah. And then it has a so like at the top says statistical test, and it goes to quantitative, categorical, or 2 quantitative variables. And then you can fill it out, but so it kind of breaks it down into there. So we're talking about 2 different samples here, and neither one are dependent on each other.
Oh yeah, did you guys want to just go ahead and like do this on the quiz?
Yeah, that's where
where
I'm
I'm
putting it in at.
Looks the same thing.
Yeah.
Sorry, my internet's freaking out sometimes.
Do you live up in Rexburg?
What?
Do you live up in Rexburg?
Yeah.
Where do you live at?
At the gates.
Cool.
It was just my internet disconnected for a second there, so.
Oh, no worries. I was just curious.
Like that sounds right. I was just trying to remember like independent, like what makes it dependent versus independent or paired.
Paired is if they're dependent on each other. I'm pretty sure.
Mhm.
In the flow chart, it has another spot, but I'm not sure. It says two quantitative variables.
In that flowchart attachment thing you're talking about under quantitative?
Well, it has quantitative, and then it has all that stuff. But there's three arrows coming directly down from the statistical
Yeah,
test.
2 samples, 1 sample, 3
Well,
plus samples.
No, above that where it says statistical test, it says quantitative categorical, and on the far right it says two quantitative variables.
Yeah.
I don't know which one that is. So I have all the ones that are written on the options. I have them labeled where I think pretty sure where they go. Anyway, I think we can go with D on that one.
Yeah. Is it my turn to read?
Yeah, go ahead.
For number 4, a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 240 were classified as heavy players. I believe 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis?
I think I have G.
I do too.
2 proportions?
Yeah.
Yeah.
Yeah, I think so.
A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in this study. Each student was given the combination to each lock and asked to open the locks. The time it took for them to open each lock was recorded. They wanted to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis? I did independent sample t-test.
That's what I have too.
Okay.
I wonder where they came up with some of these ideas for like tests. Like,
Seriously?
Some random stuff.
I'm really bored, so I'm gonna test that, see which locks easier to open. Weight gain during pregnancy of the mother is an important indicator of infant health. A simple random sample of pregnant women in Egypt, Kenya, and Mexico was used to determine if weight gain during pregnancy differed in these 3 countries. Which hypothesis test would be most appropriate?
Is it ANOVA?
I think so.
That's what like. The ANOVA's like if it's more than 3 or 3 or more.
Yeah. Are you guys putting periods in when you're putting letters in too?
I was just
No.
putting the letters.
I am too.
Is it me again?
That's Cambria.
Oh.
Deciding which confidence interval to use. Here is a list of confidence intervals we have studied so far this semester. For questions 7 through 10, identify the one confidence interval that is most appropriate for the given situation. You may use a confidence interval once, more than once, or not at all. In the answer box, type in the letter A, B, okay. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same type of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study?
Would it be the +4 interval for 2 proportions?
+4 confidence interval with 2 proportions.
So F?
Yeah.
I think that's right.
Yeah, I would think so too. I don't see anything else that.
Stands out. For that one.
No. Okay. Is it me now?
Yep.
Okay. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting that they were satisfied or very satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be the most appropriate for this study?
I'm guessing it's E, because I remember reading about this.
C?
E?
E?
Yeah. What do you guys think?
The only thing I'm hesitant is that it talks about two different things again.
So then would you think that it's the +4 with 2?
Are we on number 9 now?
No, we're on 8.
No.
8 still?
What do you think for 8? Daniel?
I'm just reading through it one more time.
Oh, sorry.
Let's see.
Because I mean, technically, there's one subject, and they're saying whether they're satisfied with it or not. But then again, that's 2 populations.
Yeah, I can see how it could be E, and I can see how it could be F, because you're right, it's like one topic, but there is satisfied or very satisfied.
Yeah.
So I don't know.
Two majors.
Hmm?
Two majors.
Let's do that.
Percentage of psychology majors. Percentage of accounting majors.
Oh, then I'm going to have to say it's F.
I don't like these questions.
On the one with the inference with 2 proportions, on your lesson 18, it talks kind of gives a similar example. It talks about like the heart attacks on the weekdays, heart attack fatalities on the weekdays, and then versus the weekends.
Mm.
And that was for an inference with 2 proportions.
Okay, so then it would be F.
Yeah.
So for 8, we're going with F.
Yeah.
I think so.
Okay.
Okay. O'Hare International Airport in Chicago has a reputation for having a large proportion of its flights being late. You designed a study to see if this reputation deserved. You find that the average on-time rate for international airports in the U.S. is 70%. You collect data and determine the on-time rate for O'Hare. You decide to construct a confidence interval to compare O'Hare's on-time rate to the national average. Which confidence interval will be the most appropriate for this study? Would it be the 1 proportion?
Which one did you say? The one sample or?
Yeah, the one proportion. The +4 confidence for one.
So E?
Yeah, because I mean, you aren't calculating that confidence interval, you're just comparing it. Did I understand it right?
You collect data.
1 second.
I don't know. Because they're comparing it to the national average. So I'm wondering if it's D. But like you said, they're not necessarily, I mean, they are getting some data, but I don't know.
Okay.
But it does sound like they're getting a proportion of stuff, too.
Yeah.
E and F.
We've done F for the last two. I don't think you should do 3 Fs in a row.
Okay, I'm okay with putting D.
D?
Yeah.
Oh. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreos and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean, filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this test?
I said the one sample t-test. With the one sample t confidence interval.
This is hard because this is stuff that we learned a long time ago.
Yeah.
Long, like a couple weeks ago.
Yeah, it feels like a long time ago.
Yeah, it doesn't say that they're. You and some friends said you want to know the true resolution. So we're doing a sample of 55. I think you're right.
Which one of the following best defines the notion of the significance level of a hypothesis test?
Did you say for that? Did you say B for the last one?
Uh-huh.
Okay.
You agree with that, or do you have a different idea?
Let's see. That's like it's just been so long since I've read through the one sample t-test stuff, so.
Yeah.
That sounds right, but.
Yeah, that's what I was thinking, because there's one population, and we don't really use the z-test that often. So when we were just doing one population, it was the one sample t.
Because the only difference between a T and a Z test, I think, is if the sigma is known, right?
I don't know. But it doesn't say there's a sigma that's known.
Yeah.
So I'm going to go with B.
I'm okay with that.
Alright, so we're on 10. Who's reading?
Me. Which one of the following best defines the notion of the significance level of a hypothesis test? probability of rejecting, whether it's true or not, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true, the probability of the type 1 error, or the probability of a type 2 error.
Pretty sure it's B.
Yeah, I think so.
Yeah.
Yeah.
Okay. Well,
Is it me again?
Yep.
Okay. Which one of the following best defines the notion of the p-value of a hypothesis test? The probability of rejecting H naught, whether it is true or not, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true, probability of a type 1 error, or the probability of a type 2 error. Cool.
I think it's A.
Yeah, because if p is smaller than your level of confidence, then you reject.
Yep.
Okay. Suppose you create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 95% of the data are between 10 and 20, 95% of the sample means are between 10 and 20. There is a 95% chance that the true mean is between 10 and 20. And 95% of all 95% confidence intervals actually contain the true mean. I think it's C.
C?
D.
Mm.
It's D. Because in the reading, I remember reading the ring, it says you do not read this saying there's 95% chance.
Oh, yeah.
Which one did you say it was?
D.
D?
Yep. I don't know why mine's like this. That's just what I think.
right, you're right.
I'm pretty sure I've read it, but I could be wrong.
Yeah. Sounds right.
You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in the town who invest in the stock market is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportions?
Say it's D. Then 15, I did the calculations. It comes out to 0.046.
I'm trying to remember, is this lesson 16 stuff? I don't
I
recognize
think
it.
so. I just remember that with this one, the mean is the same as P.
I remember reading something like that, yeah. What's the formula you used for that one? Is that
You take the square root of P multiplied by 1 minus P divided by N.
okay?
And it comes out to like 0.0458.
So, and that P would be point.
That's 0.30.
Make sure I understand that.
Sorry, I had to go get my calculator.
Oh, no worries.
What was the formula you said you used?
You take the square root of p multiplied by 1 minus p divided by n.
The x. What lesson was this from?
16.
So is this the p hat or whatever it is?
It's not p hat yet. I think that's the next lesson. Stop.
Because under lesson 16, that's what it starts off with. We're talking about the p hat. Describing categorical data, proportions, sampling distributions, and the sample proportion.
Yeah. If you go down to the bottom at the summary, or even before that, so the standard deviation of p hat would be p, the formula she said.
1 minus p divided by n.
Yeah.
Okay.
What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
Oh, what did you guys get for 14?
We put D.
0.30?
Yeah, because Megan was telling us that P equals, what were you saying, Megan? P equals the sample value.
Yeah. I just remember us doing a question like this, and p was the same as the mean.
Yeah, right here. The sample proportion p hat is normally distributed. If n is large, the true population mean of the random variable p hat is mean equals p.
What did you get for this? 15? Sorry, I was out of the room.
Cut 0.046, because when you do that formula, that's like 0.0458.
Okay.
And then I don't remember how to do 16.
And now I'm trying to go through and read 16, lesson 16, see if I remember the formula.
Guys, we only have 2 more weeks.
That's
No.
nuts.
Megan, where did you find number 16?
I didn't do that. I can't
Oh, you didn't do that one? Okay. I'm just trying to find where it is, and I don't.
I'm guessing it would be on the same one.
Yeah.
1 second. My husband had to go to urgent care for his eye, and he's calling me.
For his eye?
Yeah, I think he cut it.
Cut his eye? That's not good.
That doesn't sound fun at all. Like, that sounds terrible.
Is he getting stitches?
Okay. I have to go. I'm in the meeting. Okay. So, like, for the past couple of days, his eye's been really red, and he, like, felt like there was something stuck in there.
Uh-huh.
And that's how, like, I felt when I, like, gouged my eye. But apparently he has, like, pink eye.
That's no fun.
Mm. Okay, are we still trying to find 16?
Yeah.
Okay. Oh, no.
I feel like we have to use the probability applet. I'm trying to remember what we have to find, like the z.
That's what I like did with the probability app. Like I did some equation, but it came out to like being like 0.58 something, and that's not an easy answer. But I'm probably doing it wrong.
Like those numbers you don't care.
Oh, it's been a long day. Use the z-score you computed in question 11 to find the probability of the proportion of successes p hat will be greater than 44%. The calling this class to any constructible times. In other words, find p. 4. Freak.
Value. What was the standard deviation again?
Well,
0.0%.
okay.
Not for sure. I think it's A. Because in less than 16, it gives you the z-score, which is the value minus the mean, divided by the standard deviation. So you go 0.25 minus 0.3, divided by the standard deviation. Remember this lesson, Megan, how we kept getting the wrong
Oh,
answer?
yeah.
We were just barely off.
And then we started making up our own.
I think, and the one I typed in, it's pretty close to 0.138, so I think that's what it is.
Yeah.
Oh,
I'm
it
not
is.
gonna say.
Yeah, so I think it's A.
Okay.
I think it's your turn, Daniel.
For questions 17 through 21, use the following information. Acupril is meant to control hypertension. In clinical trials for Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril, and the 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. The other of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experienced dizziness but did not take Acupril. Create a 95% confidence interval for P1 minus P2. Would this be a two-sample z-test for proportions?
It'll be a two-proportion test. Um, 95% confidence interval. In my Excel, I got C.
How did you enter it in? Did you put the 1,563 as X1 or what?
1563 should go as N1, and 579 should go as N2,
Okay.
and X1 is 61, X2 is 15.
So you're saying A?
C.
Oh, okay.
That's what Excel gives me.
You got C?
Yeah.
That's what I got as well in Excel.
Okay, are you ready for the next one?
Yep.
Okay. Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Use its level of significance of A equals 0.05. So for this one, I think I got B.
B?
Yeah, because they're saying that the null is that they're the same, and then the alternative is they're not the same.
Yeah.
I agree.
The value of your test statistic is, I got 1.458.
Is that the z-score?
Yeah.
1.458.
Yeah.
Yep.
I don't know why. I always end up getting like one of these wrong on the quizzes, and it drives me nuts.
And then your p-value. What is your p-value?
0.145.
Okay.
Okay.
Is there
So
sufficient-
then we failed to reject, right?
Yeah.
Which one did you put?
That we would fail to reject.
But I'm trying to. Oh. So I think it should be the last one, because no, I failed to accept the alternative.
Okay.
Because the fourth one says no, I rejected the null. She's trying to trick us. And 5 says no, I failed to reject the null. Well, I guess it could be that one.
Yeah.
The second to last one?
Yeah.
I think it's 5, right? Or the
No,
fifth
I
one.
can't reject the null hypothesis.
Yeah. Sorry, I read that one. I read that one wrong.
Okay.
So I think it is 5.
She did trick you.
She
You
did.
done been tricked.
Done been tricked.
Okay. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypotheses for this study are being a morning or evening person is independent of age, or being a morning person or evening person is dependent on age. The results of the survey are given here. Use this table and the information above to answer questions 23 through 25. Conduct a test of independence. $177, 210, 200, 210, 190.
Would you use a chi-square test for this?
I believe
Yeah.
so.
Okay.
Calculate the test statistic for the hypotheses test. 6.580.
Yep.
Yeah, that's what I got.
P-value I got is D.
0.087.
Yeah.
Yep.
Yep.
Should you reject the null hypothesis or not explain?
I think it's the second to last.
Second to last one, no. The p-value is greater than 0.05, so you would there's insufficient evidence to reject.
Yeah. If the p-value is high, the null must fly.
Nah.
Good way to remember it. Do you have sufficient evidence to conclude that age makes a difference in whether a person is a morning person versus a night person? Why or why not?
The last one. We failed to reject the null.
Yep. Is it?
I don't know who it is anymore. We just booked through those.
Yeah.
Go
Question
ahead.
26 and 27. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, a 95% confidence interval of P is...
I'm pretty sure it's 0.195, 0.315. I think this is the one sample Z test for a proportion.
Sounds
Plug
good to
in.
me.
So 127.
Yep.
Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with confidence, 95% confidence? And then use the prior estimate of 0.2 for this estimate.
I tried to put in the, because this is on lesson 17. I tried to put it in, but I didn't get it right. So I'm going to do a different, because there's like a bunch of different formulas.
Yeah. Remember, it's n equals z over z times the margin, and then you square that.
Which one are you using? This one?
Because we're trying to find the sample size. So isn't it the
This is
n equals the z over the z times the margin of error?
We can determine a sample size we need to obtain a desired margin of error by using the formula n equals the z critical number divided by m squared, or p times p whatever per parentheses 1 minus p for prior. It's in the summary at the bottom of lesson 17.
My question is there's a couple different formulas, because I typed in the one that says if we have a prior estimate for P, plug it in that, and we do have a prior estimate for P, which is 0.2. I
It
plugged
says
in
that no prior estimate is available. The formula is the critical z number 2m squared.
I know, but it gives us the prior estimate in the question.
So we would use that first formula.
And I typed it in and got a really different answer. Because the z, according to this, unless it's greater than or something. No, see. The z it gives me is negative 10.104. So I don't know. That's what it. We can try it.
What are the critical z numbers again? What is the critical z number for 95%?
95% is 1.96, I think.
Yeah, I think I have it written down somewhere. %90 is 1.645.
95%?
Is 90%. 95 is 1.96.
Okay.
It could be that one. It could be C.
And m stands for our margin of error, correct?
Yeah, I believe
Yeah.
so. I think it's C. That's weird though. That's not very high.
Well, the thing is that in the previous one for the 0.2, or, well, anyways, in the previous question for the 95% error, it was 200 was the sample size. Wait, never mind. I confused myself.
See, I got the second one. I got 1,537.
And what formula did you put in?
I put in the formula that it gives at the bottom of the page for lesson 17, where you have in the first parenthesis brackets the critical Z number divided by the margin of error, close parentheses squared times the whatever that P, the prior estimate, so times 0.2 parenthesis 1 minus prior, or 0.2. I got 1,536.6.
See, I'm getting 15.366. What am I doing? Oh, I see. I'm putting 0.2 instead of. Okay, yeah. I was putting 0.2 instead of 0.02.
Okay.
Okay.
Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performed better than other investment managers. Conduct a hypothesis test. Use level significance 0.05. Which of these is the most appropriate for addressing this question?
Suppose you wish to see the
Would it be C?
I think so.
Yeah.
How many measurements must you have in order to assure that p hat is normally distributed? Is it?
I'm pretty sure it's C.
Yeah.
Yeah.
The value of your test statistic is...
Is this going back to the same one we were just working on?
I have no clue. That's what I was just trying to figure out.
That's kind
I
of.
think so, because it has
No,
the
it's
same...
not.
No?
Because this is the test statistic right here.
No.
That's weird.
So, yeah, I'm confused on, are we using the same stuff that we had for questions 26 and 27, or?
See, that's the thing, because it says that on 28, it says use the following information for 28 through 32. But it doesn't give us any, like, numbers.
Yeah.
Suppose you wish to see if there's evidence that graduates of one of the top business programs. It's talking about business programs. So it is talking about 26 and 27. It is talking about business programs. But I'm confused because my test statistics numbers are way. My computer's frozen. See.
What did you guys get?
Go up.
got like 0.0598, but none of that.
0.2. Bam! I'm a freaking genius.
Okay.
Hold on. What's the type of test we're checking? Greater than. The test statistic should be 1.768, I think.
How'd you get that?
So in the Excel spreadsheet, the one sample z-test for proportion,
Mhm.
in the inputs, you put in your confidence level, but then you change null hypothesis because it was at 0.6, and we're checking our null is 0.2, so I put in 0.2, and the type of test is greater than, right? That's what we decided on.
Okay.
And then the p-value should be 0.039.
So then we would reject the null.
What did you say the p-value was?
0.039.
Okay.
I think. So then we would reject the null.
Mm-hmm.
Oh, let me just check something. Is there any net numbers in there? P-value.
Okay. I submitted it.
So did I.
So
And I
did I.
got 2, 3, 4, 5, 7, 9, 11, and 12 wrong.
So basically all the ones that are asking about the types of tests.
Types of test.
Yeah.
That's annoying.
So you guys just study up on them.
Those are just confusing sometimes.
No, they all seem the same.
So question, like, what do you guys, like, I know I joined your guys' group, like, today. For the final project, what all are you guys doing, or what can I do to help out with that?
For our project, we each got 5 different packages of those original Starbursts, and we were counting to see
Bags of them, or the small
no,
tube?
just the little packs, little bar thing.
Okay.
And we got them from different, because I'm in North Dakota.